Okay, hello guys, in this video we want to talk about the antiderivative of secant of x dx, alright? Okay, so I'm not going to be using any short approach. I'm going to solve this straight, and this very plentiful, but it's actually a very awesome way, alright? Now, we know that the secant x is the same thing as 1 over cosine of x. So I would like to rewrite this as the antiderivative of 1 over cosine of x, and I put down the dx like this, alright? Okay, so the next thing I would like to do is to go ahead and multiply cosine x on the top and bottom in the integrand, so I can rewrite that as the antiderivative of, so I'll multiply the top by cosine of x. That is cosine of x times 1 is going to be cosine of x, and on the bottom, I'll put down cosine x times cosine x, so that if I just cancel this, let's just say cosine of x, and I'll multiply with another cosine of x, and I'll put down the dx. So you see this on blue just cancel out, and we are still left with 1 over cosine x, which is the same thing as secant x. So we haven't changed anything, alright? Okay, so by computing this, we're going to have cosine x on the top, and on the bottom, we're going to have cosine of squared x, and I put down the dx like this, alright? Now, the next thing I would like to do is to split the bottom. We know that cosine of squared x is something as 1 minus sine squared x. So if I just put that down, the antiderivative of cosine of x on the top, then on the bottom, I would just like to put down 1 minus sine of squared x like this, alright? And I'll put down the dx like that. Okay, well, from here, I would like to make a use of, if I make a u, let's say we just want to do a change of variable to reduce the complexity of this integrand. So if I make u, okay, I'll say let u be equal to sine of x. It means that the u will become cosine of x dx like this, alright? Okay, so if that is the case, it means that this right here, I can change it, alright? Cosine of x dx, this is just it. Cosine of x dx, like that, alright? Don't mind this dx, it's still on the top. So the whole of that, I will replace it with du, because they are just the same thing, when u is equal to sine of x. So at the bottom, I'm just going to replace sine square x with u square. Since u is sine x, that means u square will be sine square x. So that means I'm going to write that as the antiderivative of, on the top, I'll just put down the du, like I said. Then on the bottom, we're going to put down 1 minus, in place of sine square x, where u is sine x, we're going to put down u squared, alright? Okay, so the du is just on top. Well, I would like to continue over here. Now, the next thing here is that we are going to look at this as, I'm just going to look at the factors of that denominator. Let me just put it down, 1 over, then 1 minus u squared. We can factor this, alright? Maybe we just look at 1 as a perfect square, 1 squared is something as 1. So that will give us 1 minus u times 1 plus u, alright? When we have difference of 2 squares, we can factor it to get that. Okay, so in the integrand, we have seen an expression with linear factors. I would like to decompose this to partial fractions, alright? Okay, and the way we do it, we're going to put down the factors. Maybe, let me just work with the integrand, then I'll plug it in backwardly into the integral side, and we will get what we want from there. So maybe I'll just work with the integrand. I will have 1 divided by 1 minus u times 1 plus u, and let me decompose this. Let me put down the first factor, and then let me put down the other factor, alright? Okay, so since these are just linear factors, at the top we're going to have a degree less, alright? So that will become a constant according to a partial fraction decomposition when we are talking about the linear factors. Okay, well, since these are just linear factors, there is how we are going to do it. I will use the Coveral method, which will be a little bit faster, alright? I see that the denominator, to solve for a, alright, I would like to multiply both sides by the denominator of a. Now, okay, to solve for a, I would like to cover this denominator up. I'm going to cover that up by making the denominator to be 0, alright? So for this denominator of a to be 0, u here will be 1, alright? If you plug in 1 here, you're going to have 1 minus 1, that will just be 0. Okay, so I'll come to the left-hand side. Wherever I see this factor, 1 minus u, that is 1 minus u, I will cover it up and I'll plug in that 1 into the other factor and in the numerator. So that 1 that will make this to be 0. So we just plug that 1 in here. We're going to have 1 plus that u, which is 1. That will be 2. So we have on the top, there is no u, so we are not going to substitute 1 for any u on top because u there is just 0. The power there is just 0. Okay, so we have 1 over 1 plus 1. That will be 1 over 2. And that right there is the value of a. So to solve for a, find the value of u that will make the denominator of a to be 0. So we're going to do the same thing for b. The denominator will be 0 if u equals to negative 1. So we come and cover that factor up and plug in negative 1 into the other factor. We're going to have 1 minus negative 1. That will be 1 plus 1. That is 2 in the denominator. On the top we just have 1. So this will become 1 over 2 again. Okay, so that means that this right here can be written as 1 over 2 for a. So I would like to rewrite that as 1 minus u, alright? So this is just the 1 over 2. Then 1 over 2 for b. So this is 1 plus u, alright? So in the place of this, I can just write this, alright? And at once, I would like to split the integrals at once. So we're going to have the antiderivative of 1 over 2 times 1 minus u, then du. Then we just add it with the antiderivative of 1 over 2 times, let me just put the 1 here, 1 plus u, and I'll put down the du like this, alright? Okay, great. Well, to work this out, I'll just put down the 1 over 2 in front. Let me just put it down here. The antiderivative of 1 over 1 minus u du. Look at this. 1 minus u in the denominator. The derivative of the denominator will give us negative 1, alright? So we would like to have negative 1 on the top. So I would like to multiply the top by negative 1 so that we have negative 1 on the top, alright? Okay, but I'm going to multiply negative again to cancel out with the negative. That is, negative of negative 1 is giving us positive 1, which is the same thing as this, alright? So here we can comfortably write this down as negative of the antiderivative of 1 minus u, because we know that the derivative of the bottom will just give us the top. Okay, so I would just plug that answer in. So let me do it straight now. So we're going to have 1 over 2 is out, then the antiderivative of 1 minus u, and don't forget about the negative 1. Okay, so the next thing is the antiderivative of, let me just put that the 1 over 2, antiderivative of 1 over 1 plus u will give us just 1. So that will become natural logarithm of 1 plus u, like that, alright? Okay. Well, maybe if I just clean this up. Okay, so the next thing I would like to do here is to go ahead and simplify this a little bit. We see that this negative 1 over 2 as a constant multiple with the logarithm. Okay, so we can just put this up. We're going to have the natural logarithm of 1 over the square root of 1 minus u, right? Where the exponent is going to be negative, so this expression will come down, and this is 1 over 2 as a power, so that's just like saying square of that. Okay, so we add it with the same thing here, but this is positive, so we just put it down on top. Square root of 1 plus u, right? Well, we are going to take only the positive square root, so let me just put this down. Maybe you just do it here, and the same thing here. Okay, anyway, by this, logarithm to the same basis, so we're going to multiply the numbers and take in single log. So we're going to have logarithm of this times 1, that will just be square root of 1 plus u divided by the square root of 1 minus u, like that, alright? Okay, very nice. Well, from here I would like to work with this number alone. Maybe when I'm done, I'll just plug it back, alright? Okay, so what I would like to do here is to look at this number as, okay, let me just put this down. Square root of 1 plus u divided by the square root of 1 minus u. Well, I would like to multiply the top and bottom by this on top, okay? So I will just multiply it, square root of 1 plus u times, okay, divided by the product of that, 1 plus u again. Okay, so if you multiply that on the top, you just see that we're going to have 1 plus u, alright? You know, square root of 1 plus u squared. because the two things are just the same. Okay, and on the bottom, we're going to enter with, well, this is a square root and this is a square root. We take a common square root, and then we just multiply the radicands, we choose to call it that way. So that is 1 times 1, which is just going to be 1, and negative u times positive u, that is negative u squared, alright? Okay, now you multiply this, and then this one, they will just cancel out. Okay, just like that. And you recall that u was equal to, that u is sine x, alright? So we're just going to plug in sine x in place of u. We're going to enter with, this is going to give us 1 plus sine of x divided by, well, square root of 1 minus sine of squared x. Well, you know that 1 minus sine squared x is cosine of squared x, and the square root of that will just give us cosine x. Okay, so maybe I'll just clean things up a little bit, and then I will equate this to that. But remember that we were working with only the number, okay? So we'll just put down the natural logarithm. Okay, so I'm going to rewrite this as 1 plus sine of x divided by, like I said, cosine square x, and the square of that will just give us cosine of x. Okay, so let me just remember to put this down. Maybe I'll just put this down like this. Okay, so I would like to split the fractions here. I'll put this down as natural logarithm of 1 over cosine x plus sine of x over the cosine of x. Alright? You take the 1 over cosine x and take sine over cosine x. Since the denominator is just the same, we're just going to add the numerators and we're going to get this back. Okay. You see that 1 over cosine x is secant x. Alright? And then sine x over cosine x is just tangent of x. And that right there is a natural logarithm of that. So maybe we just add an arbitrary constant and that ends it. Okay, thanks for watching and please subscribe to my channel.